This lecture is on electric fields. It says, by recognizing that the chemical atom is composed of single separable electric quanta, humanity has taken a great step forward in its investigation of the natural world. So basically what we want to do in this unit is we want to create a map of the electric force at the various points, kind of like a topographical map where it'll show you the elevations. We want to do the same thing, but we want to do it with force. So the goals for this presentation are two. Number one, you need to be able to construct an electric field and predict the motion of a charged particle in that field. You need to be able to calculate the magnitude of the electric field at any given point. And you also need to be able to understand what the role of the electric field is in a capacitor and what a capacitor's function is in your everyday life. So number one, the electric field. The electric field is the cause of the attractive and repellent forces. It is always drawn from positive to negative. Okay, that's just a standard definition. Whenever you draw this, you have to be very, very careful that you indicate the directions on the arrows. If you do anything other than that, if you just draw lines like these outside ones are, these are incorrect lines because it doesn't show you drawing them from positive to negative. It produces a map that's similar to a topographic map in the fact that it shows you the direction and also the number of arrows and how closely these lines are together are an indication of how strong the field is or how strong the force is if you were to put a particle there. Now, you can calculate the magnitude of the electric field by simply taking the force and dividing it by the charge. Now, when you do that, you get basically this. You get Coulomb's law, which is missing one of the charges. So remember, Coulomb's law was F equals K Q1 Q2 over R squared or D squared. All we did was we took one of the Q's out. When you take one of the Q's out, what you get is you get the term the electric field. The electric field is measured in newtons per coulomb, or sometimes it's actually measured in what's called volts per meter. They are the same thing, and we'll show you that a little bit later when we talk about voltage. But for now, newtons per coulomb is actually more common because we're going to be dealing with forces divided by charges. The electric field is particularly relevant whenever we talk about a capacitor. Now, a capacitor is an object that you can wire into a circuit that actually stores charge and then is released at a certain point, either when the plates get closer together or when the charge reaches a certain point, it's discharged. Now, you have a series of capacitors right here. They're all different sizes from 2.2 microfarad, and you see some bigger ones right here. These things are actually kind of dangerous because you can actually charge them and you can store them, and they carry that charge with them, and they actually can shock you. One of the things is if you've ever taken a TV apart, on the back it says, do not touch this even if it's been unplugged. The reason why is a television has capacitors that are charged. They're actually high value capacitors that are charged, and even when you unplug it, they're still charged. So if you were to unplug a TV and then go touch it, you would still be shocked. A capacitor consists of two plates. They're both conductors that are separated by something that's called a dielectric. Now in here is some sort of dielectric material which can allow the flow of materials to go through it whenever it's polarized generally. It has to be polarized usually in order for that to happen. But the dielectric is an insulator that can be polarized into something that allows charge to flow. So it's kind of like a semiconductor in that it's an insulator that can be converted into a conductor. So you have these two charged plates which create an electric field between them. And the strength of that electric field plays an important role when we talk about circuits. Now, a capacitor is these two plates that produce the electric field. Whenever they're discharged, it allows the charge to flow through the circuit and actually allows something to occur. You most often see capacitors, kind of a really small example of a capacitor is RAM memory. So computer language is in binary, which means it's either on or off. Okay, there's a 1 or a 0, it's on or it's off, which means a capacitor is used to store binary information. Something is either charged, which is on, or it's uncharged, which is off. And that's the easiest way for a computer to tell if it's a 1 or a 0. Now the combinations of those 1s and 0s are actually what lead to information. But probably a more common use that you guys may recognize is that in remote control devices. Whenever you push down on a keyboard, what happens is you are actually taking one of those plates and you're moving it closer together, which makes it easier for it to discharge. Whenever that happens, you get the key that's actually pushed on the computer. Now, if you were to take that and you were to hold it down, you wouldn't get a continuous stream of H's or G's or whatever you're you're pushing. You would get them and they would continue to go, but there's a time gap. It's not infinity G's in a row. And the reason why is that capacitor has to charge and then discharge, and so there's a time gap whenever you hold the button down that you can only go so fast. Now, you should know, learn, memorize, recall all of the information that's related to the electric field. You should be able to predict the motion of a charged particle in that field. You should be able to determine the magnitude of that electric field at any given point using those two equations that we showed. And you should also be able to understand how a capacitor functions. And we will be looking at trying to construct some capacitors in class to show that they actually function. If you're really interested, if you have an old gaming system or something along those, you can take apart your remote control and you can actually see the capacitors that are involved in things like the firing button.